Manure solid-liquid separation is a practice that seems to be relatively simple, but has many different moving parts that need to harmonize in order to make a positive impact on the farm. In this unit, we'll dive into what this practice is, how it is being implemented, and why it could or could not be economical for animal agriculture operations. In theory, this concept couldn't be any more simple. It's just the division of materials, in this case manure, into solid and liquid components. Dealing with manure on a farm is definitely a love-hate relationship, and asking someone to handle it even more can really turn a lot of farmers away from the idea. But if we can enhance the value of that manure that the farm produces per year, and still have adequate processing and storage ability, it might just be worth it. So how is this done? There are four main categories, or methods if you will, of manure separation. There's gravity, mechanical, which involves screen separation, belt and screw presses, and centrifuge, drying, and chemical separation, which we won't talk about too much because that's kind of a gray area. So we'll start off with gravity separation systems. And with this you have about a 3-foot deep concrete area where you push off and allow it to sit for a certain period of time. And in doing so, the gravity actually will pull the solids from the manure and allow the liquid to stay on the top. And after a certain period of time, the liquid will drain off and be moved to a separate storage area. But retention time is definitely key here because the longer you allow it to sit in these holding bays, the more smaller particles that are allowed to settle and the less overall nutrients that you have in your liquid. You can also add alum, which increases separation, and this kind of goes in with the chemical separation because you can kind of intermingle both the chemical and the gravity, and that just pulls more phosphorus and other smaller solids from the liquid stream and keeps that in the solids. This is also one of the cheaper methods of solid liquid separation simply because all you have is about a 3-foot deep pit, maybe 4 depending on how you really want to do it, but it can really save you a lot of money in the long run as opposed to the others, which require a lot more input costs, which we'll talk about. So moving on to mechanical separation, this is probably the most common category of separation techniques that are used today. The first is screening, just using a screen that ranges from 1/1/10 inch to 1/100th of an inch thick, and the solids stay on top and the liquids pass through. Now these don't work for every species, so for dairy they usually have a higher solid particle size, so they tend to stay towards the 1/1/10th, while you have hog farms that are typically to the lower end of that scale, the smaller screen sizes. But 1/150th inch is optimum for phosphorus removal, which phosphorus is a huge deal, especially today with all the loading issues. So having that as a baseline can really, if you have the manure that will work well with that size, you can really optimize your phosphorus removal this way. Next we have the pressing method, which is just using a belt or screw press, and that applies pressure to remove the liquid from the solid. So it still has a screen, but it's just using that force to push the liquid out. With this method, typically there's more phosphorus in the liquid stream just because it's not really separating, it's just driving all that moisture out, and phosphorus is very small, so it wants to go out the screen. It doesn't want to stay and stick with the solid as with the other methods. This is best when it's followed with another method just to reduce moisture further, and it also is, in my experience, is one of the most common that I've seen. Moving on to the centrifuge, That just uses your G-force, so it spins it really, really fast and forces all of these large particles to the outside. The small particles and the phosphorus kind of stay at that intermediate, so it all depends on what your time is spinning it, and the liquids will just stay in the center. The most common style of centrifuge is the decanter, and the speed and time of that is really the driving force behind how good of a separation you're getting. So now lastly we have drying separation, which is driving off any moisture via heat or evaporation. The only thing is with evaporation, it only works in warmer climates, because you're not going to see in Wisconsin it get warm enough throughout the year to evaporate any significant amount of water, if at all, off the manure. And also, it can be done up north, but you really need a lot of heat, and that's going to really drive up your energy bill, and it's not going to make it economical. So this is the least economical that I've seen as far as separating the solids and the liquids. So what do we get from this separating of solids and liquids? Well, you have the solids, and that's primarily where your high phosphorus and nitrogen levels are. That's where you're going to get all of your good fertilizer from, your good compost that you can sell. And for dairy farms specifically, you can reuse the bedding, and basically what that involves is it has to go through a heat, but once it does, it can either be heated or composted, and that kills the pathogens, which then it can be used as a bedding again, because it's basically sterile. The only thing is that if you're using it for dairy, the increased frequency, bedding frequency is needed, just so it doesn't keep building up. And avoid moisture, because anytime you get moisture, some pathogens are bound to still be there, and they're just going to regrow and cause problems for you. Now with the liquid stream, this is where you tend to have lower phosphorus and nitrogen levels. It can be, depending on your method, you can have high phosphorus or high nitrogen levels, but typically it's lower. And this is primarily used in irrigation to save water. You can flush your alleys with it, or you can have it treated and discharged actually. The biggest thing I see with this is out in California, if they want to do this, it would be a great way to conserve water for irrigation and whatnot. By breaking our manure down into solid and liquid components, we can actually help with our greenhouse gas emissions and somewhat of an ammonia emission. So what happens during the process of separation is actually the greenhouse gas compounds are actually locked in, and they don't tend to stay out and produce methane like they would in standard slurry storage systems. In turn, this would drop our nitrate production, so it's aerated, the solids are aerated, which would keep that from producing methane, and it would lock that nitrate from converting into nitrous oxide, which is actually 264 times more damaging than carbon dioxide, so that's always a positive. And overall, there's a 19% decrease in greenhouse gas emissions when you separate the solid and liquid, and that's on average, but it's still a pretty significant decrease when we're looking at climate change as a whole. The only downside is our fossil fuel use will increase, just because we have to still run equipment, we still have to use energy to separate, but the greenhouse gas emissions are being reduced, so that's always a positive. And there really isn't a significant ammonia change, just because with anaerobic digestion, it makes the nitrogen more readily volatile, but if you're managing it right, there really shouldn't be that much of a change between processed and unprocessed manure. So what are some of the things that affect the economics of this whole separation process? Well, particle size is the first, and that's basically you're affected by species, what kind of feed you're feeding them, the bedding that you're using, the storage of the manure, and like how you're handling it. But particle size really makes a difference as far as separating. your solid content, which consists of your total solids, and that's broken down into total suspended solids and total dissolved solids. Your moisture content is huge because you want to drive off as much of that as possible, and that can be varied based on, like in a dairy for instance, you have misting systems or rainwater that you're allowing to go into your manure system. You want to limit that as much as possible. And finally, the type of manure. So, kind of goes back to the whole species thing, whether it's a slurry, whether it's a solid, and yeah. So, if you look at the graph here, you can see how moisture really affects it, and that's one of the biggest things is with the economics is as your moisture increases, the value of trucking that manure somewhere else decreases dramatically. And you really want to minimize that as much as possible, which separation allows you to increase the value of the truckload and how much you can fit on it. So it makes it more feasible to ship those nutrients off the farm. Now that we know how this sort of works, we can look at the good side and the bad side of this investment. On the good side, we have that we can sell to an alternative market. So we can sell our compost, we can sell soil amendments to other farmers. So that brings in revenue for the farmer that they didn't have before. The bedding for dairy is huge because you can reuse your bedding, and that will save you on your input costs for your operation as a whole. Hauling also decreases just because you can fit more tonnage on a load and ship more away. Your nutrient contents are higher, so you can get better fertilizer out of it if you're growing your own crops or if you're selling the compost or whatnot. And with the liquid, there's a lot less agitation just because you don't have that crust and the sludge down in there because you took that out with your separator. So you don't have to agitate and release all that methane. It's just a whole lot better for everyone. Now on the bad side, this is where the money really kicks in because it's such high fixed and variable costs. So you have to buy the equipment, which can be upward of $10,000 to $50,000, and that was back in 2014. So it's a lot higher even today. You have to manage the solid and the liquid different. So yes, you have to have labor. You might already have that, but you have to still take the time to have separate storage. You have to have separate application styles. You might have to have somebody come in and do it for you. It's just a matter of managing two different things instead of one like before. So that can really make a difference for some farms. So the bottom line all comes down to what method you really want to use and what you're willing to use, the management style that you currently run, and innovation. So a lot of farmers now are getting older and they really don't want to change their ways, but if you can show them that you can make their manure more valuable by doing this, maybe they will come around. But it all comes down to their willingness to participate in this. And most importantly, it comes down to the money, because the hard times that we're facing in agriculture, you're not going to get any farmer who's right in their mind to put money into something where it's not going to benefit them. They need to make money off of this, and it can be done, but a lot of factors need to go just right in order to do that. So this can be a really good method of moving your farm into the 21st century, but you really need to just take the time and look over your options and pick the best method for you. I think this is something that could really be beneficial in the future, and it could really give agriculture a good perception to the public, because we can do this in an economical and environmentally friendly way. We just need to put a little bit more research into it, and I feel like this is something that could really take farms into the new age. So just to summarize, pick the best method that fits your operation and do your best to enhance the value of that manure, because this can be a great tool for farms to utilize their resources more efficiently.